Have you ever wondered what the difference between organic and inorganic compounds is? It's a question that may seem simple, but the answer is anything but. It's a tale of carbon atoms, complex molecular bonds, and the fundamental building blocks of life as we know it. It's a story that takes us from the deepest oceans to the farthest stars, and it's all part of the amazing world of chemistry. So, are you ready to embark on this journey of discovery? Well, buckle up, because we're about to dive into the fascinating world of chemistry to find out. First off, let's talk about organic compounds. Now, don't let the name scare you. It's not as complex as it sounds. Imagine a bustling city where all the buildings, roads, and bridges are made of carbon atoms. That's how organic compounds work. They're like the concrete jungle of the microscopic world, built primarily from carbon atoms. But it's not all about carbon. These compounds often invite other elements to the party, like hydrogen, oxygen, or nitrogen. Think of them like the different types of shops and businesses that make a city vibrant and diverse. Now, where do these compounds come from? Well, they're primarily derived from living organisms. That's right! The sugar you put in your tea, the amino acids that build up your muscles, they're all organic compounds. These compounds don't just form simple structures, no, they love to go all out, forming complex molecular bonds. They're like intricate puzzles, each piece fitting together perfectly. So, in a nutshell, organic compounds are like the intricate puzzles of chemistry, with carbon as the main piece. On the flip side, we have inorganic compounds. They're the simpler relatives in the family of compounds. Unlike their organic cousins, inorganic compounds typically lack carbon. They are often less complex, more straightforward in structure. But don't let their simplicity fool you. They have their own unique charm and vital roles to play. These compounds are not just found anywhere, they originate from natural processes like the formation of minerals in the Earth's crust, or even from human-made experiments in laboratories. It's a bit like cooking, but with elements instead of ingredients. To give you a taste of what inorganic compounds are, think of everyday substances like table salt, known scientifically as sodium chloride, or baking soda, also called sodium bicarbonate. These are inorganic compounds, and they're essential in our daily lives, from seasoning our food to making our baked goodies rise. So, you could say that inorganic compounds are like the basic building blocks in the vast Lego set of chemistry. Now that we know what organic and inorganic compounds are, let's highlight their key differences. Picture this. Organic and inorganic compounds are like two different types of puzzles. Organic compounds are those complicated 1,000-piece jigsaw puzzles, while inorganic compounds are simpler, smaller puzzles. Why is that, you ask? It's all about the composition and complexity. Organic compounds are made up of carbon atoms and often include hydrogen, oxygen, or nitrogen. They form complex molecular bonds, like the intricate patterns of a large jigsaw puzzle. On the other hand, inorganic compounds are simpler in structure. Think of them as smaller puzzles that are easier to put together. They typically don't contain carbon, but don't underestimate them. Just like a small puzzle can create a beautiful picture, inorganic compounds such as sodium chloride play essential roles despite their simplicity. And what about the number of puzzles? In the world of organic chemistry, there are approximately 19 million known carbon compounds, while in inorganic chemistry, there are about 500,000. That's a lot of puzzles. So, whether it's the complex puzzles of organic compounds or the simple building blocks of inorganic ones, both are incredibly important in the grand scheme of chemistry. Well, there you have it. The difference between organic and inorganic compounds simplified. We've journeyed through the world of carbon-rich organic compounds, abundant in living organisms, and delved into the simpler, yet crucial, inorganic compounds like our friend sodium chloride. In this scientific saga, we've discovered that organic compounds form complex molecular bonds with a whopping 19 million known carbon compounds. On the other hand, inorganic compounds, though simpler in structure, play essential roles in nature and our daily lives, with around 500,000 known compounds. It's essential to grasp these differences not only for budding chemists but for anyone with a thirst for science. The understanding of these compounds and their differences is a cornerstone in the vast and fascinating building of scientific knowledge. Remember, whether it's organic or inorganic, it all adds up to the amazing world of chemistry. So keep exploring, keep learning, and stay curious.